Porosity and permeability is another activity that we have in this section, and it asks the question, how can you use models to show porosity and permeability? Models can help students understand difficult concepts by simplifying them. This lesson helps students visualize porosity and permeability. Porosity and permeability are two characteristics of rocks that help to explain the locations of crude oil and natural gas underground. Rocks have different abilities to hold water. This is called porosity. Rocks also have differing abilities to allow water or other materials to flow through them, and this is called permeability. This activity models both porosity and permeability of rocks using sponges. At the end of the exercise, students will determine which sponges have the highest porosity and permeability and discuss the limitations of sponges as models. So here are some rock models from different sponges. A microfiber sponge, a sea sponge, a cosmetic sponge or a loofah type sponge, and we also have a scrubber sponge. We've already cut these other three sponges to fit, so Paul, if you'll help us cut that one to fit the container that it's in. Now what we're going to do is pour 25 mils of water on each one of the sponges and allow it to either absorb or permeate through, okay? Pour slowly, otherwise it'll run off the sides. You may need to take a break as you're pouring to just allow for it to either absorb or to permeate through. Now we'll let that one sit while we pour into another one. Yeah, let's start with pushing it in a little bit further. There you go. So as you're watching, you can see that there are some differences between each one of these sponges. This one was a lot more permeability than there was in the first one. And there's our third example. So this is our scrubber sponge. Yeah, we need to measure that out. So is it acting like you thought it would?
Yes, actually even more so than I thought it would. I was expecting, because this is so dense, water would kind of sit on top of it, but this barely seems to be absorbing. I think
Yeah.
we got, if I wasn't mistaken, 1 drop of permeation.
We may have to let that sit for a minute or two while we measure the other ones, and we'll come back to it. How about that? All right, so what we want to do is we want to measure the amount that's in the bottom of the cup as well as the amount that was absorbed by the sponge. The trick is getting it out without squeezing all of the water out of it. Got it. This would be the amount in the sponge itself, so this is showing porosity. Not very much.
Yeah, we collected, I'd say, about 2 milliliters.
Okay.
We can use this as our little
Yeah,
waste
receptacle cup. There you go.
And
then measure, what's in the bottom of that cup. Let me set this over here. Wow.
yeah, it comes into about 17 milliliters.
Okay.
Seems to be a little more than the microfiber, though.
Mm-hmm.
But you're right, not by much. So the sea sponge held only about 3 milliliters.
Okay.
Permeated 20.5 milliliters.
Wow. Now we'll pick up with the mesh puff. It's a cosmetic kind of sponge.
Yeah, that's about 1 milliliter.
Okay. It's permeability.
Yep. Ability, we get about 20 milliliters right on the dot.
And then our scrubber sponge has done nothing.
nothing at all.
The water just sitting there. So how this relates to oil and gas is that there are some rocks that are very good at trapping oil and gas so that it will not migrate any farther. And this scrubber sponge actually is acting like a trap. In this particular instance, we would have really no data about permeability or porosity because there is no absorption even from this sponge. So we can just put zeros there.
In a way, if you were to look at these, as rocks in the ground, sandstone would be more akin to the sea sponge. Way more porous. You have a lot more porosity and ability to retain moisture, whereas this scrubber would be more akin to, granite or marble, where we actually see, almost no absorption or permeability or porosity in it.
Right. And another term that the industry uses for those are cap rocks as well. So thinking about this activity, which sponge had the highest porosity? Really, our sea sponge did. How do you think these sponges work for models?
I think that they give a simpler representation of how rocks can act in accordance to moisture. Obviously, with the analogy, the sea sponge would be akin to sandstone, whereas the scrubbing pad is closer to granite.
So these are just, again, good representative models for students to understand porosity and permeability. Now, I do have 4 other models that I created that use golf balls and materials like foam to indicate different types of rocks. So these models, again, are my representation of talking about, for instance, the first one with the golf balls that have holes in it. That's kind of like conglomerate. So we have some porous spaces, and if you put water through it, water would come out the bottom. But then I have some hollow golf balls, so it would be really difficult for water to permeate into a closed container or a closed rock, but there are big pore spaces inside that rock if the water could permeate into it. So it's not real clear which rocks those might be modeling, but again, it's showing that they're big pore spaces, difficult to get into. So it may be very similar to shale. Shale rock has a lot of pore spaces. They're not very big though, and it does take a lot to permeate into those rocks. I have one that's also solid golf balls, and those solid golf balls in a rock would represent maybe granite or marble because there really isn't a lot of pore space. There's no place for it to go. And then I also have another smaller, not using golf balls, but Christmas lights. Christmas lights, those mini lights have very small pore spaces. That model, again, might be more akin to shale because the pore spaces in shale are very, very, very small. So we have models. You might ask your students to give an attempt at trying to create models of their own to help them explain the porosity and permeability of different types of rocks. Another lesson in this section on porosity and permeability does give ideas for an activity where students can create their own rock models.